Hello everyone, chapter 13, collections. So what's a collection? It's an object that serves as some sort of collection of other objects, in other words, repository. The collection should have methods, services for adding, removing, and otherwise managing the elements it contains. Collections will be generic. They are generic in Java, and it usually holds a specific type. An example of a collection is an array list of something, in this case strings. If you remember, previously we created array lists of various objects. For example, there was some objects like trolls and elves, if I remember correctly. So we had common interface for them, which was play chess or whatever, and there was array list of chess players. So collections, elements in a collection may be ordered. Think lists. For example, lists are ordered by index or unordered. Those would be sets or hash tables. Hash tables in Python, hash table dictionaries in Python correspond to hash tables in Java. There are slight differences, but in general, that's what it is. All right, so collections are implemented in a variety of ways, and collections are implemented using underlying data structures. For example, array list is implemented using linked list. This is actually a doubly linked list. We will talk about it later, but for now, it's just another thing. It's a very similar thing in collections. And also using an array. Both represent sort of the idea of a list and behave in similar ways. All right. Collections, like all objects, are abstractions. They hide underlying details, they describe data and provide tools to work with data. Those would be the methods. We want to always separate interface, or whenever we're dealing with something sophisticated, separate the interface from underlying implementation. The reason being, we reduce complexity. We allow to work with objects, or in this case data structures, using the interface and not worrying about the underlying implementation, which can be changed by whoever is developing it. So this is really a big use of object-oriented programming. It's a way to manage complexity and change the implementation without changing interface. And we have seen examples like that. So basically, an abstract data type or is an organized collection of information and set of operations used to manage that information. So we don't really care that much how abstract data type or collection is implemented, as long as we are able to work with it using its interface. And those are two very similar terms, collection and abstract data type. So we will use them interchangeably. Now on to dynamic structures. A static data structure has a fixed size. An example would be arrays. Arrays are static, which means when they are declared, once the Java knows the size of an array, it actually allocates the memory for it. You cannot add an element to an array, or you cannot, if you don't need the last element in the array, you can replace it with null, or with some default value, but you cannot change the size of the array. So it is faster. Static data structure is faster, but it is not as versatile. The meaning of static in this context is different from the static modifier. We remember that static modifier is the static is a modifier to declare a class variable which does not depend on an instance and doesn't require any instance of from the class to be instantiated. So for example, a static method is a class method, and we call it by calling the class name dot that method, as opposite to dynamic methods, which we call by instance dot method. So back to the static versus dynamic. Dynamic data structure actually grows and shrinks at execution time as required by its contents. And we remember, for example, to an array list, we can keep adding items and they will be stored. For a dynamic data structure, we need object references, which we will call links. Let us remember that part of the story. We have a variable student, and the student variable should help us deal with an object from the student class. But in reality, the student variable is not holding an object, it's holding a reference to the object, or otherwise a pointer to this object. And in context of links, I think pointer is more ubiquitous term, but they are essentially the same. So the value of the variable is basically a pointer, an address where the object is stored. Alright, we will shortly implement something like this, class node, and we can store some information, some useful information, as well as a reference to the next node. And next is the name of the variable. Node is the type of the variable, so it is also a class. So that's what we are going to do, and let us see why we're going to do that. We want to create a single linked list. Single linked means that the arrows go only one way. We only see the next element and we cannot go back. The list variable, sometimes it's called a head, is pointing at the first node on the list, and inside this node there is information, whatever that may be, and then the next is the reference to the next node. In the end, the next is referencing null, that is nothing, and that's how a single list is. So having a single list, we can choose to add something to the end of the list, or add something in the beginning of the list, remove something from the list, remove an entry from the list, or we can choose to reverse the list. Some of the things we will do right now, some of the things you can find in the example, which is what the homework is about. It's about the magazine rack example, and you asked to add something to this code, but you will be the ones to do that. Okay, so I'm creating an example of a linked list from scratch, and I will want to add something to the list, and I will want to reverse the list. So note this, the list variable points to the head of our list, to the first element. And we should not change that unless we know what we are doing, because as soon as we change, if the list now points to the second node, the first node has no longer variable attached to it, and it's garbage collected. Alright, so let us try to do it. So I created a node class. It's not a big deal, it's just a couple of integers. Let me remove the private modifiers. So we have a number and a node. Let's go with info to conform with the way the book is. Let's conform it with book notation and naming. So this is info. So as you kind of guess from now, from this, this is automatically generated constructor, and we need to modify that. I don't need to pass a node as a variable. In fact, soon I will make the node class hidden, private, inside the single list, because we don't need to create nodes by itself, only as a part of the linked list. So next will be now by default. And this works. We can uncomment this couple of lines of code and do something interesting with them. While we're at it, okay, I guess I need a setter for a moment. I will remove this setter soon enough. All right, setter for next. Okay, so this will instantiate instance object from the class node with info3, and then we will set next to be the same, and that is something that linked lists don't do. So you don't want, ignore this for now, what you don't want to have, you don't have want to have a circular reference in a linked list like this. So this is not what you want to have. Let me erase it real quick so that it doesn't bother us anymore. Bear with me. All right. So I made sure that it works. I can run it and make sure that it works. And after that, I want to hide my node altogether. So it did work. Let's delete this, and now I'm going to make this class private. I'm going to copy paste it over here. In the end of my single linked list, there will be a private class node. Doesn't need to be public. And we have no use for set next. No need for set next. So now it is a private class. Only the single linked list will know about it. It's a helper class, which will help us create the single linked list. So you can examine this code. I want to create a list, and I want to populate it with certain values and then print everything on the list just to see what's going on. So that is the first plan, and then we will want to do insert in insert first and maybe insert to the last position like append. And that is what the example is about. So we want to create something like this. This is a single linked list. It holds values 3, 5, 7, and each node will reference the new node, and in the end they reference null. And my variable for holding to this list will be just a link variable or list variable pointing at the first node. All right, let's make it happen. So private node list oh, oops, wrong place. And I will need to create a constructor for it. we don't need a default constructor. We just create it with null for now. So it's pointing to null instead of an object of class node. And immediately we need to create a way to add items to my list. So public I will call it add, just like the book does, public void add, and I will be for now adding an integer named new info. Alright, so we want to add to the end of the list. So first of all, if my list is currently empty, if list equals to null, let's say that list is now equal to the new node containing new info. And that's it with the first case. Else I will need to create a variable that will keep track of where we are on the list. So the purpose of this variable would be to run to the end of the list. So current will start as list. Okay. And it will run to the end of the list. While loop, of course. While loop, and then it will create a new element. It will create a new element with some value, and it will delete the reference to null and reference over here, and this one by default is referencing to null. That way we will be able to add to the end. Alright, so else we are creating a new node variable, current equals to null, and while current dot next, let's see, while current.next is not equal to null, there is something after the current, we will say that current dot next current equals to, so we are shifting. So while the next exists is not null, we can shift. And in the end, we should define current dot next equal to new node new info. So we are actually creating a node with the information that we need. All right, and just to test that it works, or if it works, we will need to right away do the print. So the next method will be public void print. Let me check the wrong place. That's why it does not want to do it. Control P. Public void print. Let's keep it. Actually, let's close this and window, and that will create more space for us to see. So we're just printing everything. I will need again the same contraption with a current variable. Again, we don't want to change the value of the list unless we know what we're doing, because list variable points to the head of the list. So we want to create a new one, and while node current equals list, and while current next is not now, we will need to print the value system.out.println current dot info. So we're printing our information and then shifting to the next one. So the problem with this code currently is that this can point to now, and maybe I should do while current is not now. We print current info and then looking for the next one. And we have an error here, probably because we have mismatched braces. Alright, so let's try to create a... Now we can delete this. Delete. Alright, let's try to uncomment this. Single linked list, okay. Single linked list, alright. And we will append 3 things to it and then print it. Control plus slash. Oh, oops, it's called add. I changed my mind on the names of the functions while I was developing it. Alright, let's see if it works. Cannot read the field next because current is null. Also, it did not do anything. So in the main it was line 8. So it added 3. I may have forgotten to create here a link. So this should be to now and current equals to list, of course. Rerun. Here we are. So we created a list with 3 elements, and right away in our method for printing we might need to say something like, this is your list. Sorry. the list elements. All right. We are just checking that everything works as intended. We are halfway there in terms of uncommenting the code, but we are not halfway there developing our program. Okay, now there goes the interesting part. We have added to the end of the list. How about we add to the beginning of the list? And the best way to do it is to create, to first understand what we're doing. I'll use a simplify. Okay, don't need that. New. Don't save. I'll use a simplified notation like 3, 5, 7, and now. And I want to insert a new element 1. Now currently my list is looking here. My list variable is looking at the head of our list, and I want it to look instead over here, which means that I'm going to erase this arrow. So that would be the first thing to do. And when I'm defining this new node with 1 in it, I need to set up the reference to reference the next element. So I guess I will do that first, and then I will redefine the list. Okay. So doing that, and the name of the method is insert first. Okay, public void insert first, and we will insert the integer new info. And how we will do that, we will create a new variable node new node equals to new node with new info. Oops. Info. And immediately set up new node dot next equals to list. What will this do exactly? This will, when I'm creating the new node over here, what will this do? It will actually follow to look at the value of the list variable, and my next will now be equal to the list variable, which is originally referencing the value on the list, current head of the list. And then we're actually removing this and instead pointing at our newly created object. So now list equals to new node. All right, so now we need to test whether insert first works. And also we need that. All right, let's try to print after we added an element. All right, so I added to 357 on the list. I added 1357. And now we need to do the reverse. So this is the most interesting part we're going to do today. How we're going to do it, let's think. Again, I just need a new one. Okay, so I have my current list. 1. This is sort of thing where you need to plan a little bit on a paper or on a screen while what I'm doing. I will need to produce the list, like my goal over here will be the same values, only in the opposite order. And now this one will point to now, and my list variable will be over here. Okay, so currently what we have is the list variable over here and null pointer over here. The only way how we can do it, we have to run in a loop and reassign the pointers. Now, reassigning the pointers, how to do that in general, you kind of have to think about how you do it at first, on the first step, but how to do that in general, you are considering kind of a generic moment when you reassign some of them. This is my list forming up, and this is the leftovers that I still have to deal with. And to be efficient, although it's not necessary, I can be moving the list to the head of my bad, sorry about that. I need to reverse the arrow. My arrows will be reversing, so this will be 1, 3, 5, 7. And I can do the reassignment of list variable in the end, but I need some variable to keep track of this location anyway, so this will be my list in the middle of the loop. And I will also have to have two variables, one pointing to previous and another pointing to next. And because next is kind of already used, I'm gonna say next node, if that is okay. And using these two variables, I believe you cannot do with less than 2 extra variables. And instead of using list over here, I could be using current. That may be more intuitive at first. That's what I did in class earlier today. And I will need to carefully reassign them. So let's start writing the function itself. So public void reverse here we are. So I need to create two new variables, node previous, I'm gonna call it prev, and originally it will point to null, and node next node, it doesn't have to point anywhere. Now let us look back at the picture and think about it. So what if my list was empty, or my list consisted of just one element and then one node and then null? I don't have to reverse anything in that case. So I can assume that my list consists of at least 2 entries. That will be helpful for us. So first of all, if list is list.next is not equal to null, that is not a list of single, or maybe list not equal to null first. Let's check that we are not dealing with list of length 0. If list is not equal to null, then while list dot next, no, it cannot be next, because maybe it can be. Okay, list dot next, I'm going to be moving the list as I'm reversing the values, not equal to null list.next will be next node. List.next, actually next node will be equal to list.next in that case. And then I will need to, I saved the next element because I'm about to break up the connection to the next element. The current connection to next element. I'm going to say that list.next equals to previous. On the first step, it will take care of reversing the list and creating a null over here. And later we will save as previous the current, the list. Okay. Now previous equals to list. So we are shifting everything now. We are shifting everything now, and then list.next list equals to list.next, or next node. List equals to next node. Doesn't matter. Actually, it does matter. I cannot do list.next because list is now pointing backwards, and next node is actually holding the old next value. We already reassigned our list. And I think this should reverse the list if I'm not forgetting anything. All right, let's do that. I want to uncomment the last two lines. So I have 7, and then my node broke. Somehow I don't have my link backwards, so I'm not done yet. I need to find list.next, and we shifted the next. List next equals to previous. And previous was previously null. So on the first iteration, when previous is null, if list is not empty, the list next is not null, then we're performing this. But that has likely worked well. And on the last iteration, we know that list.next equals to null, and list is currently pointing at the last one, and in this case this is not executed. So when I need to execute this once again, and that is all, I think. So on the last iteration, my list next was not null. Last time it was not null, this ran. The list variable shifted to the very last one. And in that case, all we have to do is just reverse the link in the node. And I think we're done. Here we are. So we have reversed the order of the list. This is a typical algorithmic problem, basic algorithmic problem. If you have a single linked list, reverse the order of the list. And notice that one of the nice things we have done, we have hidden our private helper class node outside of the single linked list. We don't need to know what is a node, how it works. It just works. So that was the big example for the day. And I think it's very closely related, this kind of thinking that we used over here in reverse function, very closely related to inserts, and you can look up find the corresponding discussion about the insert in the book. There is a hint there how to insert things, for example. And look at this nice example on which the homework is based, magazine rec. It's basically we create a list of magazines, and then we want to remove something from the list, and originally it's not in the code, and it's a nice example to actually do that. Alright, and that is all for the day. Enjoy the homework, enjoy the little assignment, and before I finish, make sure you start on the big project, the semester project. I don't think it requires any kind of custom made list. Another nice idea, what you can do is try to make it work with a generic. So currently our node only takes integers, which is kind of restrictive, not what we want. We want to take a generic type here. So we want to work with any type and have it supplied in the driver as a variable.